afternoon, everyone. Let's start the webinar. Very welcome to this webinar. Today, we have two parts in this webinar. First of all, Mr. Low, our group manager of Printed Intelligent Device Group, will give you an introduction and overview on printed flexible hybrid electronics and e-textile for advanced wearables. Follow that, I will give an introduction of our master course, e-textile and advanced wearables, and also another training course on flexible printed electronics and applications. Without further ado, let's start. So, Ms. Lo, please.
Yeah, thanks. Mashan, is my slides okay?
Yes.
Okay. Yeah. Good afternoon, colleagues and friends. I see a few familiar names. Thanks for joining this afternoon for this sharing. So I will start with some introduction about these technologies in the flexible hybrid electronics and also the electronic textile, in short, e-textile, mainly targeting looking at the for advanced wearables device developments. So I'm locked here. I'm taking care of a group on the printed intelligence under the FlexTech and the MedTech manufacturing division. So today, this is the 4 topics, subtopics that I will cover in my presentation. We talk about the advancement of the wearables, introducing about flexible hybrid electronics, and also the electronic textile, and what are the outlook and the future forecast of the product devices linked to the technology itself. So as we see for advanced wearable, a lot of time we see that the application is starting from the sport wear. We are seeing now, especially during the COVID, and a lot into personal health. We have awareness of the personal health development, and actually more into a medical application. And after this, we are seeing that whether we can go into a much wider reach of the consumer in the public health, and at the advancement of other technology, whether you can come into helping us in the health, in the assistive technology, as well as the helping us in how we perform our daily job, or even in the rehabilitation after injury or sickness, that will actually help us in the daily life, that is moved into some sort of a soft skeletons. So looking at the technology itself, I think that is where on the smart tracker and watch this we are familiar today. So there are 2 key trend technology that move into e-textile base, and on the apparel, on the wearables that they put it on. And another stream, so looking at electronic skins that actually can direct like a patch that attach on the skin to collect the biometric information for even including others bio fluids as well. With the even advance in the technology, researchers are looking at building other intelligent and even functional into a fibers that actually currently is a form of the fundamental element they make a textile. Then you can use it for more intelligent type of a functional, or even looking at storing the energy as well as generating the energy itself. So typically we see in the sensor that are able to detect our body biometric or some signals, including like the brain wave, like our heart rate variation, ECG, respiration rate, our oxygen level in our blood, SpO2, and also our muscle signals, and then come into the monitor our gait through the foot, the pressures and location, as well as the sweat and temperature. So that will develop into a different form factor of the devices, including headwear, the shirt and the pants, as well as footwear. Also, some of them into a smart arm and wristband, including others, multi-sensor node apparel that connecting each other with a different type of a sensor that we have a better holistically view of our human signals. So in order to realize this function, we have a C constraint in the convention electronic, which is pretty rigid and pretty bulky in a sense. So we are looking into joining flexible hybrid electronics factors that we can look at a different type of a form factor into and utilizing different material base. So for example, in the contact lens space where the electronics, circuitry, and functionality can build on top, or you can actually build on some form of the PDMS elastomer material that become a skin patch as a second layer of the functional skin, or integrated into a polymer structure or on the surface that conventionally electronic board are not able to conveniently doing so. So as much as electronic textile as another platform that apply not only for human as a wearable, it can be as like a wearable for even for your furniture, like in the chair, or even for animals health monitoring as well. So as large, we break into two broad category where we see there is one part is could be a stretchable, electronics, flexible, and built into electronic textile. And on the other hand, you have different features that can build into the structure. So with these two technology have a different application that can work independently. And also we are seeing a convergence of these two technology that be able to address some of the challenge in terms of the functional devices. So for example, the soft skeletons, and also in the health assistive and also performance assistive type of technologies. So let us take a look into the electronic textile application. So broadly, in the current application space, there are four broad categories looking at heating, biometric, lighting, and others application. I will touch on a bit more on the first three. Others including, say, they are emerging form into the exoskeleton for the soft robotics, as well as automotive interior. So for example, in some of the seats, as well as in the control panel on the surface that are using fabric. So they are a small group of people looking at how this technology can apply onto the animals to understand the health condition and also recovery from injury as well. So there are four different types of category in terms of a technology where how we can build functionalities on the fabric itself. So the first one, looking at, we can do a direct ink printed onto the textile, which is conventionally this has been done on the t-shirt. There we have print a different graphic on top. So now the functionality need to be built on the conductive ink or other type of functional ink that can directly adhere onto the fabric, as well as can withstand the wash and wear, stretch, and so on. So they have a different characteristic required for this ink. The second one is the technology have been also utilized in fabric technology industry, which is means like the inks are printed on the transfer film, and then that is like using iron to hot laminate onto the textile. So this is some form of a film transfer. This is the technology itself is pretty common in the apparel manufacturing. The third part is that how we actually conductive yarn is like connecting the printed circuit board as well as some of the electronic components such as the LED onto the fabric apparel directly. So to perform electronic function like such as lighting and so on. So the fourth one is that using the functional yarn to form the sensors itself, for example, some of the healthcare, to create certain strain sensor, and also through the expansion and contraction of this type of a yarn structure, and to sense the changes of the electrical signal, for example, to capture the respiratory rate condition. So in the application of heater and para, so there are also couples of application domain where, like, the first one is for sport. They have been used in the motorcycles, into the skiing, and so on, the apparel, to warm up the athletes during the sport activity or even before the activity. So for the workwear, industry have been looking it to apply like a heating onto the glove and also the cold room attires, so that we can improve the workers' activities in such a cold environment. And the third part is quite well known, where for like general tourists like us, we can need it to actually when you go for a cold country in the winters. And the fourth part is really health and wellness, where you can use heat therapy to actually cure some of the injury bruises as well. In terms of lighting, quite commonly you can probably see in the different fashion shows or even cinema films that we have been using for as a fashion, as indicate. But there is an emerging area where the using for LEDs and the phototherapies to actually perform some of the therapy purpose, for example, in terms of wound healing, and also the fat reduction, like regenerating the hair and so on. So we have a fabric like LEDs, like on the short clip on the right-hand side, you can see where this is requires certain form of a flexibility that you can form, and that will create some integration of the LEDs on the fabric that you can use for this purpose, that you can conform to the different application. So in the aspect of the biometric monitoring, you can see that mainly in the sport and fitness, medical, healthcare, industrial, and military, and also the last is on the animals. So on the right-hand side, you can see basically a different type of sensor and a technology that required to sense the different biosignals on the bodies, on the human bodies, and also the technology like the dry washable electrode that enables some of the measurement of electrical signal from the skin surface, for example, in the EMG, EEG, and also heart rate variation, and so on. So in a broad view, this can be categorized in a single use and multiple use in terms of wellness and medtech area. So it will be emerging in the continuous glucose the monitoring patch, the ECG monitoring patch that have been used in hospital, and so like pregnancy monitoring and so on. So in terms of right now, what we're familiar with is for the wellness, where we smartwatch have been using, and also we're seeing smart apparel is catching up. So the technology involved like previously, wet electrode have been used in a very common in the hospital setting, but in the consumer and the lifestyle setting and for continuous use, this is not appropriate for use it for a long term. So a dry electrode and especially wearable, washable electrode need to be deployed for this application to detect the body signals. So beside the sensor portion, the electronics components and other sensor actuators need to be incorporated to have a fully function. So they will have a basic microcontroller communication protocols that are able to transmit the signal that they pick up from the body. So there are a few examples like the patch on the right-hand side, and also a different type using conductive yarn to form the circuitry to make the electrical signals and also pick up the sensor signals as well. So this is a brief overview of Simtech capability manufacturing platform that enable a different type of processing capability that we're able to help in the manufacturing of this flexible hybrid electronics, and also assembly of equipment that create a different function, including dispensing, printing, and the assembly of the components. So for electronic textile, we look at the even from developing on specific function of ink material in order to able to maintain the functionality as well as the withstand the washability in the machine wash and also chemical resistant environment, such that you're able to finally integrate it into that para and do its function as well. So a typical examples over here is that where we work with collaborators. So we have been looking into developing this technology as a fitting film for the so-called heating vest for travel, and also the uniform for the cold room application. So in others development, we look at the for the capture of some of the like brainwave through in the headgear and also temperature, looking at the human this heart rate, ECG monitoring, as well as some pressure sensing to detect the foot pressure uniformity. Typically could be used for foot ulcer prevention, and also the pressure sensor that can utilize on the seat or even bed, right, for the bed sore type of a prevention and so on. So as advancing, this technology can be used for rehabilitation, and also integrating as a smart prosthetics, right, to monitor some of the recovery stage, and also the in-condition sensors that can look at the different feedback and help to improve the recovery in a much faster mode. So if you're looking at some of the more business aspect in terms of the forecast for the technology and the application, for the flexible hybrid electronics that we see, there are several. Today, what we see, we want to focus on the wearables and healthcare monitoring. So they have been expected significant adoption throughout the next wave when the technology is getting mature. And for the e-Textile, just now we have shared in the different application mode, where you see today, excuse me, the heating have been dominating, but the biometric will be picking up, as well as other application. We seeing some increases as well, especially in the PPE aspect and the workwear aspect. So that is a forecast for the next 10 years. If we keep maintaining a capture certain trend, as you can see from the right-hand side, the for the heating, for especially for the workwear and healing portion, I think it's still picking up quite clearly, and we see the biometric, I think, will pick up at the later part of this, where we're expecting a better growth rate. So in the human aspect application, these are the broad few application category that we can see from the electrophysiological signal that we can capture, understanding the motion and the posture, and as well as the safety perspective and how we use it to improve the productivity. And also when we come into a smart patch that you can collect your human body fluid and further understand even the biomarker in the sweat on the body fluid, as well as the just now showing about the smart protective application. So in a nutshell, we are seeing that there's a convergence of the from the advancing of electronic from a rigid into a more flexible, into a deformable electronic that can couple with the electronic textile to create a conformability, flexibility of the sensing and the general circuitry, and then can have a much larger contact surfaces and the conformability that cover our human bodies, as well as other application that enabling the remote monitoring of the health and witness the wellness in this area. So some of the sensor, it can be actually embedded into the structure. For example, under shoe sole, that we able to provide even further information that are not able to collect continuously for the usage of the data for improving health and the wellnesses. So with this, I would like to end my short presentation. Yeah, if you want to, I think follow on my colleagues, Dr. Xiao will share about the masterclass program, which will be review more details of the different technologies in this technologies sectors and also application. Thank you.
Thank you, Lo, for your manufacturing technology overview. A lot of information on application and the market forecast. We will have a Q&A session at the end of the webinar. So now it's my pleasure to take this opportunity to introduce our masterclass on electronic textile and advanced wearables. So let me share the screen. Oh. Yeah, look, can you see my screen?
Yes.
Okay. Yeah, I will give a short introduction on our masterclass, Electronic Textile and Advanced Wearables for IoT, healthcare manufacturing, healthcare monitoring, and other emerging applications. Okay. You may have received the email from us with the attachment file of our masterclass. This is the cover page of our masterclass. You may wonder, you may ask, what is it? What's the masterclass? So the masterclass is a 3-day classroom style lecture with case study and prototype demonstration. This masterclass will be conducted by international leaders, experts in the area of electronic textile and advanced wearables. Give me a minute. Okay. So in this masterclass, we will focus on e-textile and advanced wearables. We will dive into deep technology from the material, manufacturing technology. More importantly, we will focus on product design and product development and the roadmap development for e-textile and advanced wearables. Some case study and focus on various emerging applications for healthcare monitoring, for sports and fitness well-being, IoT, and a lot more emerging applications. There are two invited distinguished lecturers for this master class. One is Professor Henry Lee, who is the professor and the chair of the Textile Science and Engineering, University of Manchester, UK. He's also the chairman of Textile Bioengineering and Informative Society, UK. Another lecturer is Professor Wei-Sin Lee, who is the associate professor of Department of Electrical and Computing Engineering in US. Also the director of the Center for Intelligent Sensors of US. The expertise of Professor Henry Lee include e-textile material development, sensor integration with e-textile, IoT ecosystem, ICT, which means the information and the communication technology, and also e-textile based PPE development. For Professor Wei-Sin Lee, who is from US, he's the expert in integration of printed electronics with e-textile and the development of sensor and sensing systems, application development for smart sensors, smart gloves, robotic hands, and advanced wearables. Also for smart floor carpet and smart hospital bed application. He's also specialized in integration of a sensing system with IoT, machine learning, and artificial intelligence, and how to integrate printed sensors, e-textile-based sensors with IoT, improve the intelligence through machine learning for the monitoring of human activity. So I will send, after this webinar, I will send a brochure of this master class to you for more details of the profile of the speakers. I hope you can learn, definitely you can learn a lot from this master class. So what can you learn from this master class? Learn about current and future trend in product development, emerging application, and market opportunity of e-textile and advanced wearables. Understand the technology roadmap of e-textile and smart clothing for advanced wearables. Learn about advanced wearables, IoT ecosystem, information and communication technology. And learn about advanced materials and manufacturing technology for e-textile and textile electronic device and wearables. The design of smart functional e-textile for wearable product. And also we can learn about the e-textile wearable standardization. So we have a lot of case study for emerging application. Hopefully we can link this to new strategy development and a new business opportunity. Everyone is welcome to this master class. So who should attend? Directors, managers, or CEOs from the company who are responsible for decision making or strategy development for new business. So all these participants can benefit from this masterclass. All the managers and the professionals who are working on technology planning, research and development, new product development, design and prototyping, process development, fabrication, and marketing and sales. So definitely we are looking forward to more participants register to the masterclass. So the masterclass, e-Textile and Advanced Wearables, the class will happen from 15 to 17 August. But we hope you make the registration as early as possible. The registration closing date will be 5th August. The location is Singtech at Fusionopolis. Regarding the course fee for foreigners, it's 2,800, but for Singaporeans or even foreign nationals with Singapore PR or long-term visitor pass plus, so we have the subsidy from Skills Future Singapore SSG. So the subsidy is about 70%. So for Singaporean or Singapore PR or long-term visitor pass plus holders, you can only pay less than 900 Singapore dollars, including the GST. It's not so expensive, so we hope you make the decision to make the registration as early as possible. Please register online using this address, or you scan the QR code for the registration or for more information. Also, you can contact Mr. Derek Chan, who is our IDM, Industry Development Manager, for the details. For technical information or also for registration related information or question, you can ask me as well using the email. After this webinar, I will send you again our brochure. So there are all these informations you can read through, get more information, and make the registration using the address or just scan the QR code. So this is our master class. Thank you. There's one more. In addition to this master class, we have another training course on larger area processing for application in printed electronics and functional films. Dr. Kok Wai-Tai is the host of this training course, which has another appointment today. On behalf of him, I will give a short brief introduction of this training course. So this training course is designed to give the technology transfer of printed electronics, including the printing process and the application. So the participant can learn the concept and application of printed electronics technology and understand the working principle of various flexible functional films, and also get the opportunity to gain hands-on experience. It's a technology transfer the technology developed in our group to the individual participant to improve, to upgrade your skill and competition for new business opportunity. So basically, it's a combination of classroom lectures plus process and product demonstration, and also hands-on laboratory practice. So at the end of the training course, we have assessment. Then after you go through all this journey, you can get the certificate of this training course. So this program is designed for participants in industry, for the person who are related to printing, printed circuitry board assembly, and the contents are also developed for engineers who are interested in the knowledge and skill up of printed electronics and functional fields. Okay. For the course fee, for the foreigners, the course fee is 4,000. The same for Singapore citizens, also for foreign nationals who are Singapore PR or the long-term visitor pass holders, you can get the subsidy. Subsidy about 70%, so you only pay 1,200 plus. Further, if you are employee of SME companies, fully supported by SME, so you have further discount, further subsidy. You only pay $400. For Singapore citizens only, if you are 40 years old and above, you also get further discount, further subsidy. You only pay $400 for this course. So considering originally it's 4,000 Singapore dollars, considering how much you pay, it's worthwhile for you to participate in the course. So this training course will happen from 23rd August to 6th October. Totally, there are 14 sessions. Every Tuesday, Thursday afternoon from 2 p.m. to 5 p.m. At SimTech, Fusionopolis. So it's a class plus some process, product demonstration, and hands-on. So we welcome you to this training course also. Yeah, you can make the registration online or just scan the QR code for registration. Also, you can ask Mr. Derek Chang or Dr. Kok Wat Tai for more information. That's all from me. Thank you. Go back to Dr. Tom Chua. Hello. Yeah.
Hi, thanks. Hi, Dr. Chuan. Dr. Chuan, thank you so much for the presentation. Thank you so much, King, also for sharing, for the wonderful sharing you had done earlier. So I'm here to facilitate the Q&A session. Today we have our speakers here with us. If any questions that you'd like to pose to Dr. Chuan or Mr. Boon King, feel free to type either in the Q&A box or you can use the raise hand function. Then we'll unmute you where you can ask the questions in person. At the same time, I'll actually be releasing a poll to understand your interest level in a particular program. Do take some time to actually answer the poll. And having said that, we actually have our first question from an anonymous attendee. Is asking whether this program is actually a hands-on program or a classroom knowledge sharing session. Dr. Chuan or Boon King, would you answer this? Boon King, would you answer this?
Sorry, can you repeat the question again?
The masterclass, is it a hands-on session or is it mainly a lot of classroom knowledge transfer?
Yeah, I think this one Dr. Shan can take on.
Oh, okay. It's mainly focused on classroom lecturer style, but we have some demonstration of the prototype. Also for hands-on for the so-called the testing or the some operational operation of the e-textile and wearable device, so we can touch and see. Yeah, basically, yeah, it's a classroom style lecturer.
Okay.
Yeah.
All right, great. Thank you so much, Dr. Shan. So we have another question asking about the challenges that adopt FHE and e-textile technologies. Dr. Shan, could you share with us what could the challenges be to adopt these technologies?
Yeah, can you repeat the question? Excuse me.
Yep, the challenges to adopting FHE and e-textile technologies. What are the challenges?
The challenges. Okay, maybe this is better for Ms. Lok to.
Yeah, probably I will take over this. I think that related probably to the presentation that I just now shared. So I would think that depending on your business sectors, whether you are at a product as a product owner or is a technology owner. So we look at that in the different perspective. So from a product owner point of view, we will see when we use this, right, we have to look at the overall design of the products itself, understanding the use case and also the functional requirement. Then the second step, we will look at how this can be manufactured and integrated this new function into or onto the product itself. That will be the from the design perspective and manufacturing perspective, and also depending whether you are already in the, for example, in the printing company, whether you are in the textile apparel manufacturing sectors, and also whether you are in the healthcare sector, that we can work with you in terms of these different aspects, and also probably bring in the associate partners in the supply chain to address the whole the challenge that in the whole developmental cycles. And at last, that we will actually do together with you to do a cost assessment as well, and looking at whether this technology suitability and the adoption of this technology in the respective processes and as well as the product.
Great. Thank you so much, Boon King. Right. So if there are any more further questions from the ground, feel free to ask in the Q&A box, or you can use the chat box. Otherwise, you always do a raise hand function. Or you have any questions about the funding, you can ask me directly on funding for this masterclass. For the masterclass, the funding is 70% for Singaporeans and PRs.
Yeah, okay. After this, some people asking how could SimTech help to develop a product? So after this master class or the training course, the individual company can work with SimTech for further development of the technology, like such as we start from the ideation, the idea brainstorming, and prototype development to production, and then improve the product to the market. So there are several steps we can, SimTech can work with the company for further development of the product regarding the e-textile and wearables.
Right. Thank you so much, Dr. Shan. Let's give everyone a few more minutes. Do feel free to ask any questions that you may have. Do take an opportunity to ask Dr. Shan and Mr. Boon King here today. Right, let's give it another minute. Again, do feel free to ask any questions that you may have. Yeah, please.
Any questions regarding the training course?
Okay, all right. As there's no further questions, I'd like to actually bring this webinar to a close. And of course, I'd like again to thank Boon King and Dr. Shan for speaking today. And just as I said, that we actually had a question
There's
for
a
Mr.
last word for
Eugene.
this question. Yeah.
Yes, the last minute question from Mr. Eugene. Asking whether it'd be good to understand how technology can be made acceptable as an alternative lighting solution, taking into consideration the commercial and technical aspects, such as brightness of the film and the light duration for technology. It's not really a question.
Yeah, probably we need to understand when. Okay, so for the lighting, when you say this lighting, whether we look at, I want to exclude as a general lighting perspective, because I think there will be alternative, I think existing technologies that is good for general lighting purpose. So if you want to adopt a flexible hybrid or the e-textile technology for the lighting, where we want to leverage on the advantages, right, of the technology that offer, which is conformability, that you can actually, for example, as on the cloth, you can wrap over a body or an object that is the current lighting system now are not able to do that, and it's a comfortable, it's a lightweight. So the power requirement depending on, for example, the let's say if you use it for the phototherapy, so usually the power will not very high, and a portable power that is including, if you for longer term, will be like a power bank, or if not some of the battery rechargeable battery components, it can be used for at least a few hours type of application that it actually can bring it over, bring together as a portable and movable devices. So I hope this answer part of the question.
Thank you so much.
Yeah, if you have any other question that you want to ask even after this event, please feel free to email us, or you can actually, in fact, arrange with us a visit to our lab as well, so that you can actually have a look and a feel of the technology. Yeah, so that it will be even easier to actually appreciate how the form factor will come in to facilitate the adoption of this technology and development of the new devices and the product. So I think thank you very much for all. I don't see any further question that coming in. So I think Tom, probably we can end this sharing today.
Yeah, great. Thank you, everyone. Thank you for sharing, taking our time during this afternoon to attend the webinar. We hope to see you at the program, and thank you once again. All right, goodbye all.
Thank you all. And goodbye.
Thank you all. Thank you.